This video is going to cover Chapter 4, Sections 1 and 2. So begin to talk about ratio and proportion in Chapter 4. And in this lesson, we're going to talk about how to calculate ratios, how to solve proportions, and solve problems involving proportions. A ratio is a comparison using division of two quantities of the same kind, both usually expressed in the same units. For example, the steepness of a hill can be written as the ratio of its height to its horizontal extent. And so they've got the steepness and they've got the height of the hill on the top, 10 feet, over 80 feet, and then they've reduced that fraction to 1/8. The ratio is usually written as a fraction in lowest terms, and you would read this ratio as either 1/8 or 1/8. The gear ratio of a gear system is defined as the gear ratio equals the number of teeth on the driven gear over the number of teeth on the driving gear. For example, find the gear ratio of the system shown if A is the driven gear and B is the driving gear, and where A has 64 teeth and B has 16 teeth. So if you look at our formula up here, it says take the number of teeth on the driven gear. Okay, and so that is going to be, they told us that A is the driven gear and it has 64 teeth, and B is the driving gear and it has 16. So that's how they came up with 64 over 16, and they rewrote this as 4 over 1. Now, a lot of times when we're dealing with ratios, we don't go ahead and make that be a 4 because we're trying to compare two things. There's 4 teeth in the driven gear compared to 1 in the driving gear. So we want to have both of those numbers there. And it's read 4 to 1. Typical gear ratios on a passenger car are the first gear would be 3.54 to 1. The second gear would be 1 9/10 to 1. The third gear is 1 31/100 to 1. And then the reverse is 3.25 or 3 25/100 to 1. A gear ratio of 3 54/100 to 1 means that the engine turns 3 54/100 revolutions for each revolution of the drive shaft. If the drive or rear axle ratio is 3.72 or 3 72/100, the engine needs to make 3 54/100 times 3 72/100, or approximately 13 2/10 revolutions in first gear to turn the wheels one full turn. Pulley ratios. A pulley is a device that can be used to transfer power from one system to another. A pulley ratio can be used to lift heavy objects in a shop or to connect a power source to a piece of machinery. The ratio of the pulley diameters determines the relative pulley speeds. Here's an example. We've got the diameter of pulley A compared to diameter of pulley B. And the diameter is the distance across the circle. They've got these measurements down here for us. A, you can see that is 21 inches and B is 9 inches. When they're comparing the two, they've got 21 over 9. And if you reduce this fraction, you can divide them both by 3. So that's how they're coming up with 7 over 3. And you would read that as 7 to 3. And you could write it this way as well. Notice that the units, inches cancel from the ratio. A ratio is a fraction or decimal number and it has no units. Simply a comparison. Okay, let's talk about the compression ratio. In an automobile engine, there is a large difference between the volume of the cylinder space when a piston is at the bottom of its stroke and when it's at the top of its stroke. The difference in volumes is called the engine displacement. Automotive mechanics find it useful to talk about the compression ratio of an automobile engine. So the compression ratio is the expanded volume over the compressed volume. and we have the compression ratio here. It says find the compression ratio of a gasoline engine if each cylinder has a maximum volume of 475 cubic centimeters and a minimum compression volume of 50 cubic centimeters. And so they've got the expanded volume and the compressed volume. So 475 cubic centimeters over 50 cubic centimeters. To get 19 over 2, it looks like they've divided the top by 2, and they've divided the bottom by 2 and reduced, they've divided it by 25, and they've divided the bottom by 25 to get 19 over 2. Then they came up with 9.5, okay? Most of the time when you're reducing ratios, you want the second number to be 1. So we could say 9.5 to 1. So they divided 19 divided by 2 and they got 9.5. You know that you can always, that 9.5, if we stick a 1 underneath it, still a true statement. 9.5 divided by 1 is still 9.5. So we could actually read this 2 ways. We could say 19 to 2. We have a ratio of 19 things, 19 expanded volume. Every time we have 2 compressed volume, or we could read it as 9.5 to 1. So the expanded volume is 9.5, the compressed volume would be 1. They mean the exact same thing. As we learned previously, the pitch of a roof is the ratio of rise to run, where the run is half the span. For the roof shown below, the rise is 7 feet and the span is 48 feet, and therefore the pitch is rise over run 7 feet over 24 feet. They're saying that they're not measuring the whole width across of the 48. They're saying the rise from here to here is 7, and then the run would be from here to here, which would be half of 48. That's how they're coming up with the 24 feet. Okay, roofers usually express pitch with a denominator of 12. So the pitch of the roof is 3.5 over 12, or 3.5 to 12. So to get that, we would divide both of these by 2. And remember that the feet end up dividing out. To use ratios to solve a variety of problems, you must be able to solve simple kind of algebraic equation. Consider the puzzle. I'm thinking of a number. When I multiply by the number by 3, I get 15. What is the number? Well, we know that we would have to put 5 in here. 3 times 5 gives us 15. So 15 divided by 3 is equal to 5. Let's try another one. A number multiplied by 40 gives 2,200. Find the number. Well, in order to do this, we would need to take our 2,200 and divide by 40, go backwards, the same thing that we're doing right here. And that's where they're coming up with 55. We've just solved a simple algebraic equation, but in algebra, instead of drawing boxes to represent unknown quantities, we use letters of the alphabet. For example, 40 times blank could be written as 40 times n. Furthermore, we may signify multiplication in any one of these additional 3 ways. For example, we could use the raised dot, so 40 dot n, or 8 dot 5, that means 40 times n, or 8 times 5. We could write a multiplier next to a letter, so 40n means 40 times n. Or we could use parentheses, 8 parentheses 5.6 means 8 times 5.6, or this means 2 1/3 times 4 5/8. 40 times blank equals 2200 could be written as 40 dot n, which means 40 times n equals 2200, or it could be simply written right beside each other, which means 40 times n equals 2200. To solve this type of equation, we divide 2200 by the multiplier of n, which is 40. So I do not like to use the dot when we start having algebra. So I would have written 40n equals 2200. And to get rid of the 40, we would divide both sides by 40, and those 40s would cancel out. And 2200 divided by 40 would be 55. A proportion is very similar to a ratio. Proportion is an equation stating that two ratios are equal. So, for example, 1/3 is equal to 4/12 because we could take the 1 and multiply it by 4 and get 4. We could take 3 and multiply it by 4 and get 12. Notice that the equation is true because the fraction 4/12 expressed in lowest terms is equal to 1/3. When you are working with proportions, it is helpful to have a way of stating them in words. For example, the proportion 2/5 equals 6/15 can be stated in words as 2 is to 5, right? 2 is to 5 as 6 is to 15. Cross products. When one of the four numbers in a proportion is unknown, it is possible to find the value of the number. In the proportion below, 1/3 equals 4/12. Notice what happens when we multiply diagonally. So if we take 1 times 12, which is what they've written right here, well, that's equal to 12. Let's go the other way. 3 times 4, that's also equal to 12. These diagonal products are called the cross products of the proportion. If the proportion is a true statement, the cross products will always be equal. This very important fact is called the cross product rule. If A over B is equal to C over D, then A times D is equal to B times C. Find the cross products for the multiplication 3 over 5 equals 12 over 20. And it doesn't matter which one you do first. So we're going to say 3 times 20 is equal to 5 times 12. Well, so that 60 is equal to 60. So when we do this one, now it's not really normal to write x16. It would be better to say 16x, or you could do 16.x, it doesn't matter. But 16 times x is equal to 12 times 4. So 16x equals 48. And remember, if we want to solve for x, we would divide by the number that's being multiplied by it. So we're dividing by 16 on both sides. And 48 divided by 16 equals 3. 16 divided by 16 is 1, so those cancel out. Okay? So if we start here, we do 6 times 10 is equal to 15 times n. Okay, well that's 60 is equal to 15 times n. We want to figure out what n is, so we want to divide by the number that is in front of n, that's being multiplied by n. And so we would get that n is equal to 60 divided by 15, which is 4. 15 divided by 15 is 1, so those cancel out. The unknown quantity can appear in any one of the four positions in a proportion. No matter where the unknown appears, solve the proportion the same way. Write the cross products and solve the resulting equation. We can use proportions to solve a variety of problems involving ratios. If you are given the value of the ratio in one of the terms, it's possible to find the other term. If the pitch of a roof is supposed to be 2 to 12 and the run is 20 feet, what must be the rise? So they tell us that the pitch is supposed to be 2 to 12 and it's supposed to be rise over run. They tell us the run is 20, so you notice I'm placing the runs on the bottom. What is the rise? We don't know. We're trying to figure that out. So we're going to use cross multiplication. So 2 times 20 is equal to 12 times x. So 60 is equal to 12 times x. We would divide both sides by 12. These cancel out because they turn into 1, and 60 divided by 12 is 5. So the answer would be 5 feet. For medications provided in a liquid formulation, the amount of liquid given to a patient depends on the concentration of drug in the fluid. Medication X is available only in liquid formulation with a concentration of 100 milligrams per milliliter. Suppose a physician orders 225 milligrams of medication X. This fraction right here simply means that you have 100 milligrams for every, since there's nothing listed here, you would just put a 1 for every 1 milliliter. And this says, suppose a physician orders 225 milligrams, so 225 milligrams, and we want to figure out how many milliliters that is. Notice that the milligrams would both be on the top, the milliliters would both be on the bottom. So we would do our cross multiplication. So 100x is equal to 225 times 1. So 100x is equal to 225. So divide both sides by 100. X ends up being 2.25 milliliters. The pulley system of an assembly belt has a pulley diameter ratio of 4. If the larger pulley has a diameter of 15 inches, what is the diameter of the smaller pulley? So they've given us our ratio. They want us to do the larger diameter over the smaller diameter. And so our problem says that the pulley diameter ratio is 4. And remember that we would need to write that 4 as a fraction, so we have some kind of comparison. So if the larger pulley diameter is 15, supposed to go on the top, then we want to look for the smaller. So 4 times x is equal to 15. We would need to divide both sides by 4. And 15 divided by 4 is 3.75, and this is in inches. Chapter 4, Section 2 talks about some special applications of ratio and proportion. We're going to solve problems involving proportion. So one of the first things we talk about is scale drawings. Proportion equations are found in a wide variety of practical situations. For example, when a drafter makes a drawing of a machine part, building layout, or other large structure, he or she must scale it down. It would never fit on a piece of paper if you didn't. The drawing must represent the object accurately, but it must be small enough to fit on the paper. The draftsperson reduces every dimension by the same ratio. For example, drawings that are larger than life involve an expanded scale. For the automobile shown, the ratio of the actual length to the scale drawing length is equal to the ratio of the actual width to the scale drawing width. Okay? So we've got the actual length over the drawing length is equal to the actual width over the drawing width. So they've taken our length, which is 16.6, or 16 feet, this one line, this one apostrophe means feet. If it's 2, it's inches, so 16 feet 6 inches, which is what they're writing right here. That's the actual length, but in our scale drawing it's 4 1/8 inches. Well, our actual width is 6 feet, and our scale drawing says it is 1.5 inches. So it says to rewrite all quantities in the same units. So we're going to need to change everything to inches. So if we've got 16 feet and 6 inches, well, we're going to have to do 16 times 12 because there's 12 inches in a foot, plus 6, and that's going to get us our 198. Okay, 4 1/8, it's already in inches. We do 6 times 12 to get our 72 inches, and the 1.5 was already in inches. Second, notice that the ratio 198 inches over 4 1/8 inches is equal to 48 over 1. So if you took 198 divided by 4 1/8, you would get 48. Notice also that 72 inches, which is our other over 1.5 inches, is also equal to 48 over 1. So that means that 48 is a scale factor. So the actual car is whatever you see here times 48, and that would be in inches. In this problem, one of the dimensions is unknown. Suppose that a regular room has a length of 18 feet and a width of 12 feet. An architectural scale drawing of this room is made so that on the drawing, the length of the room is 4.5 inches or 4.5 inches. What will be the width of the room on the drawing? What is the scale factor? Okay, so they've taken the actual length over the drawing length, and they told us that the actual length was 18 feet. The drawing length was 4.5. Okay, they both need to be in the same unit, so they've taken the 18 times 12 to get the inches, which is 216, and then they've got the actual width over the drawing width, so that's going to be 12 feet over, we don't know, that's our part that's missing, and 144 inches, because we're just changing them to the same units, over x, which is what we're looking for. So they've taken 216 over 4.5 and made that be equal to 144 over x. So if you'll notice, they're going to do the cross multiplication. So on one side, they've got 216 times x, and on the other side, they've got our 4.5 times 144. They multiplied these two, got 648, and then we're going to divide both sides by 216 to get 3 inches. The width of the room on the drawing is 3 inches. For the room drawing shown, the scale factor is, and this is what we had in the beginning, 18 feet over 4.5, 216 inches over 4.5, or 48, 48 to 1. 1 inch on the drawing corresponds to 48 inches or 4 feet of the actual object. One can express this as 1 inch is equal to 4 feet. A draftsperson would divide by 4 and write it as 1/4 of an inch is equal to 1 foot. Similar figures. In general, two geometric figures that have the same shape but are not the same size are called similar figures. The blueprint drawing and the actual object are a pair of similar figures. In an enlarged photograph and the smaller original are similar. So we've got the exact same shape of triangle. One is smaller and one is larger. Those are similar. Same thing here. Same thing here. In any similar figures, all parts of corresponding dimensions have the same ratio. So, for example, in these rectangles, A is in the corresponding part, same place is what that means on the rectangle as C. So we could say A is to C as B is to D because they're in the same place on the rectangles. That's how they've come up with this one. X is to P as Y is to Q as Z is to, that one should go with the S, they're in the same place, as W is to T. Okay, the triangles shown here are not similar because they are not the same shape. Okay, they're not the same size or the same shape. In order for them to be similar, one of them just has to be a reduced or blown up image of the very exact same shape, same angles. So here's an example. It says, suppose we know that the two cylinders pictured are similar. To find the missing altitude h, we set up a similarity proportion and solve as follows. So I'm going to say h. Now h would go with the height of the other cylinder here, which is going to be 3 1/4, and these are in inches. And then the 6.3, see this is all talking about the larger cylinder, and this is the smaller one. So the 6.3 goes with the 1.2, or I'm sorry, 1.5. Okay, and this, if you look across, are both of the heights of the cylinders, and these are both of the diameters of the cylinders. So we can use that to solve by doing cross multiplication. So we would say 1.5 times the height is equal to 3 1/4 times 6.3. Okay, so we would get 1.5 times the height is equal to 3.25 times 6.3, which comes up to be 20.475. Now we're going to need to divide both sides by the number that is being multiplied by the letter, or our variable, and so h is equal to 13.65, and we're measuring in inches. So that's going to be the height of the cylinder. A landscaper is designing a garden for a house that is not yet built. He needs to determine how long a shadow the house will cast into the garden area. To determine this, the landscaper, who is 6 feet tall, measures his shadow to be 8 feet long. So here's our landscaper. He's 6 feet tall and his shadow's 8 feet. If the roof line of the house will be 15 feet high, so here's our roof line, it's 15 feet high, what's going to be the shadow that it casts? So we need to compare. So here's our landscaper. He's 6 feet tall, and he casts a shadow that is 8 feet. So if you'll notice, both of these things are talking about the landscaper. This one's talking about how tall he is, and this is talking about the shadow. So if this is how tall, we want how tall the house is, and we want the shadow on the opposite side. Okay, and so I'm going to break this out for us a little bit. If you do cross multiplication, you would have 6 times S is equal to 8 times 15. That's exactly what they've done here. They just skipped a step and went directly to knowing that they needed to divide by 6 to get S by itself. So we would have 6S is equal to 8 times 15, which is going to be 120. Then divide by 6. So S is equal to 20 feet. So that's what our shadow, that's how far our shadow is going to be cast. Direct proportion. Many trait problems can be solved by setting up a proportion involving 4 related quantities, but it is important that you recognize that there are 2 kinds of proportions, direct and inverse. 2 quantities are said to be directly proportional if an increase in one quantity leads to a proportional increase in the other quantity, or if a decrease in one leads to a decrease in the other. Here's an example. The electrical resistance of a wire is directly proportional to its length. The longer the wire, the greater the resistance. If 1 feet of nichrome heater element wire has a resistance of 1.65 ohms, what length of wire is needed to provide a resistance of 19.8 ohms? Okay, so they've got the length over the resistance here, and so the length, and we're getting the 1 foot from right here, so the length over 1 foot is equal to 19.8 over 1.65, and so they're going to cross multiply. 1 times 19.8 is equal to then they're going to need to divide by 1.65. So our length ends up being 12 feet. So in direct proportion, if something is getting bigger in one thing, it's getting bigger in the other. Or if it's getting smaller in one thing, it's getting smaller in the other. Inverse is the opposite of that. So 2 quantities are said to be inversely proportional if an increase in one quantity leads to a proportional decrease in the other. So basically, if one thing gets bigger, the other gets smaller. Or if one thing gets smaller, the other thing gets bigger. For example, the time required for a trip of a certain length is inversely proportional to the speed of travel. The faster you go, so the faster you increase your speed, the quicker you get there, so the time would be decreased. The slower you go, right? The slower you go on your trip. So don't increase your speed, decrease your speed. Then the slower you get there. It would be an increase of time. If a certain trip takes 2 hours and 50 minutes, how long will it take at 60 miles per hour? So we've got our proportion. You can tell that these are both talking about miles per hour here. So 50 miles per hour, and then 60 miles per hour is what we're actually going. So they're comparing those two. If we went 50 miles per hour, it says it takes us 2 hours. And this time, look, we're putting that on the bottom of the fraction. But if we go 60 miles an hour, we want to know how far we're going to go, or how much time it's going to take us to get there. So those are inversely proportional. That's why they're not, usually we would go straight across and they would be the exact same thing. But we're doing the opposite of that. So if you look down here, they've cross multiplied 50 times 2, which is this part, 60 times x on this side. So 60x is equal to 100. We would divide by 60, and 100 divided by 60 would give you your 1 2/3 hours. A particularly useful kind of inverse proportion involves a relationship between the size of a gear or pulley and the speed at which it rotates. In the figure, B is the driving gear, okay, and A is the driven gear. Because gear A has twice as many teeth as gear B, when B makes 2 turns, A makes 1 turn. If gear B rotates at 20 turns per second, gear A will rotate at 10 turns per second. The second of the gear is inversely proportional to the number of teeth. Okay, so the speed of gear A, so if you'll notice that this is combining A and B. We've got the speed of gear A inversely proportional to the teeth in gear A. Speed of gear B inversely proportional to the teeth in gear B. In this proportion, gear speed is measured in revolutions per minute, and this can be abbreviated RPM. For the gear assembly shown, if gear A turns at 40 revolutions per minute, what is the speed of gear B? Okay, so if you'll look at this, 40 RPM has to do with gear A, right? Gear A turns at 40 RPM. And since these are inversely proportionate, gear A has 16 teeth. These both have to do with gear A. Gear B has 8 teeth, but we don't know what the RPM for B is. That's what we're looking for. So they did 40 times 16. They're cross multiplying 8 times B. And then to get their final answer, they're dividing by 8. And B ends up being 40 times 16 divided by 8, which is 80 revolutions per minute. Those are inverse proportions. On a drive shaft, on an automobile, the speed of the drive shaft is converted to rear axle motion by the ring and pinion gear system. So we've got the drive shaft speed and the teeth in the pinion gear on the drive shaft. So if you'll notice that both of these have to do with the drive shaft. The rear axle speed, so rear axle, the teeth in the ring gear on the axle. So again, gear speed is inversely proportional to the number of teeth on the gear. So that's another example where you would need to set up an inversely proportional problem. Pulleys transfer power in much the same way as gears. For the pulley system shown, the speed of a pulley is inversely proportional to its diameter. So we've got the speed of pulley A, and then on the bottom, the diameter of pulley A. Then we've got B speed and the diameter of B on the top. So you can see that those are inversely proportional. So if pulley B is 16 inches, let's just set up our proportion. So pulley B is 16 inches. So that's going to be the diameter of pulley B. So I'm just following this formula, and it's rotating at 240 RPMs. Well, the speed of pulley B is down on the bottom of this one. Okay, what is the speed of pulley A? So we don't know. We're going to put an X for the speed of pulley A if the diameter is 20 inches. Well, the diameter of pulley A should go underneath this fraction. So we're going to multiply 20 times X, and then we're going to say that's equal to 240 times 16. So we've got 20x is equal to 3,840. We're going to divide both sides by 20. So x is equal to 192, and we're talking about revolutions per minute. That's going to be the speed of pulley A. Okay, that's it for Chapter 4, Sections 1 and 2.